asks us for FT. Now, as you could see, what I normally force people to do is see the triangle that FT is a part of. It's a part of two triangles right now. All right, but I'm going to take the right angle one right here, FTS, because I have 40 degrees here, and I also have the hypotenuse, which is 181.8. So for this angle, definitely, I intend to find the opposite side to the angle. That's what they asked me for, and I have the hypotenuse. We go back to the trig ratios. Soh Cah Toa. Now, I'm going to ask myself, which one of these would have been linking to the concept, the idea that we're dealing with? Let's look. One, we have an angle. The opposite is what they want. So the opposite is in it. And the hypotenuse is already there. So I'm searching for opposite and hypotenuse. So it's going to be sine ratio, not rule, sine ratio, because it's a right angled triangle. Now, the ratio says that the sine of an angle in a right angle triangle is equal to the opposite side over the hypotenuse side. We spoke about that when we were looking at the tools. The sine of 40 degrees is equal to FT that they asked us for divided by 181.8. At this time, we are almost there. Well, depending on who you are and how you do your thing, you basically could multiply both sides by 181. All right? So you could do that. For example, we could multiply this side by 181.8. It cancels. We balance the equation by multiplying the other side by 181.8. And it's going to give us the value. So let's go about doing that, guys. Remember to confirm with me, 181.8. We're multiplying that times the sine of 40. All right, I'm getting 116, but remember, you have to confirm this. 116.8, then there's a 5 and there's an 8. I'll stop there. And then we do our rounding off based on what the question wants. Confirm with me before we start the rounding off.
Confirmed. Yes, sir.
Thank you very much. Now we're going to do the rounding off. Remember, it says all our things must be to one decimal place. So this is in the first decimal spot, and you could see that there's a 5 to the immediate right, which means the 8 will go up by 1. So we're looking at 116.9 meters to one decimal place. So let's just drop that right there. And it's another 3 marks, you know. Easily, you can collect those 3 marks. For those persons who don't round off, you'll get 2 out of the 3 for it, honestly. And you don't want to drop marks for stuff like that. All right, so that's the first question that we looked at under elevation right now. That's the first question. Is there any question anybody want to ask pertaining to that? There's another coming. Is there any question, guys? All right, going once, going twice. All right, let's go. All right, as you could see, this one comes at number 10, section 2. That was then. I think this comes at number 9 now. All right, let's look. It says the diagram below, not drawn to scale, shows a vertical tower, BT. So we're looking at BT right here, BT. All right, good. With a flagpole on top of it. So T to P is that flagpole idea, TP, mounted on it. All right, good. A point R is on the same horizontal ground as B. So they're saying R, which is here, is on the same horizontal ground as B right there. So we're looking at those ideas such that RB is equal to 60. Well, normally, as soon as I get these, I drop them on. RB is 60. So I'm just going to put the 60 meters here. And the angle of elevation of T and P from R. So in other words then, you're standing at R, you will be looking at T. Standing at R, same place, you will be looking at P. That's what they're saying. Standing at this one place here, you view two things above. No problem. Now, they gave us 35 and 42 respectively. Again, you could see that the first one is 35, the second one is 42 from R. Let's mark our angle. R. Remember, the angle of elevation is between the horizontal line and the line of sight. The line of sight means you're looking along that line towards the thing. So like, I'm just going to mark one. You're looking along that line to the thing. That's called the line of sight. So you're looking along that line. All right, good. The angle of elevation comes between the line of sight and the horizontal line. A lot of times the horizontal line will be level ground, and depending on the context, it might be from your eye, but let's see the questions that come. So this one is 35 degrees. And then we have a bigger one. The mistake I've seen made is that people tend to mark this and say 42. This is not correct. All right. Remember, there is no horizontal line up here. So then the angle must have been coming from the level ground and all the way up to that line of sight. You could put the 42 out here if you want, but it's the bigger angle of the two that we're speaking to right now. All right. So that's the labeling. All right. That's the labeling right there. And as the question said, sometime by the time I fit up what I read, I'm answering the question, label the diagram. We have already put on most things except for this. Do not leave this off, because when this is left off, we have no evidence to use what we're about to use. Everything that comes out of the ground when you're dealing with elevation and depression is at 90 degrees to level ground. Just remember that. If there's a building being erected, it's at 90 degrees. If a tree comes up, it's at 90 degrees. All right, to the horizontal. And even if you have an hillside like this and a tree must be erected, it's still going to be at right angle to an imaginary horizontal line. Nothing can work out without those ideas as we go forward based on what we will be doing. All right. So let us look at this question right now. So there it is. We realize now that we are back at a right angle triangle. Right angle triangle. We have three triangles here. Two of them are right angle triangles. Let's see what the question really wants us to find. So we would have collected 3 marks to put on those labels, 3 marks to label what they say right now. All right. All right, let's look. It says calculate the length of the flagpole, giving your answer to the nearest meter. Whenever you see stuff like to the nearest meter, to the nearest degree, here's a disclaimer. They really meant an whole number. So remember, when they use these terminologies, all they are saying to the nearest whole number. All right. So you're not going to work with any 1 decimal place or 2 or 3. No, the nearest whole number. That's what they're really referring to there. But this is their way of saying it so that 1 and 2 people might not pick up. All right, let's jump on the question. The flagpole, let's think about it. Let's think about it. We want to find this in green here, that distance. Now, let us observe this carefully. Let us look on this blue from top. This blue is from top all the way down. So the blue is referring to BP. Let's look on BP from the ground to the top of the flagpole. That's B. I'm going to put beside it a yellow marker, and it's going to be from the ground, but this time it's going to stop at T. Now look at the thing in green that we're about to embark on. Green. Watch. It starts there and it ends there. So you would want to agree that the yellow plus the green gives you the blue, which means if we can find the blue and find the yellow and subtract it, we are left with the green. And that's going to be the approach. Well, how do I label this? Well, what I'm saying is TP, which is the flagpole, it was giving right here, is equal to DP minus BT. That's what we're gearing at right now. This is what we're going to conclude at the end of the day, which means that it is our responsibility go and find BP. It is also our responsibility to go and find BT. The difference between them will give us our green light over here as the flagpole. I hope everybody saw what we're saying right there. Now, how do we find BP? Well, you have to be looking. Now, what I do sometimes is to extract the triangles because a lot of times people have problem looking at everything one time. Let us look on them at the side here. BP. If I'm thinking about BP, B is down here, P is up by the top. This is a right angle triangle. Look at the angle that we got for BP. We got 42 degrees. 42 degrees is what led to P. So this is 42. Remember, this is R, and we have RB, which is 60. Now, again, it's a right angle triangle, which means that the Soh Cah Toa is going to help us out. Why? Because I have the adjacent to 42, and I need to find the opposite to 42. Adjacent and opposite is tangent. You will realize that tangent will be used a lot. I won't say you use it all the time because the question can be changed, but they use it a lot for now. You'll see that. What we're saying is that the tangent of any angle in a right angle triangle is equal to the opposite side over the adjacent side. How does that relate to what we're doing? Well, the tangent of 42 degrees, which is this angle here, is equal to the opposite, which is what we intend to find here, which is BP over 60, which is RB, which is the adjacent side. There it is. Right now, we can just quickly multiply both sides by 60. So let's just do that. So I'm just going to write it down here. 60 times tangent of 42 is equal to BP. Now let me just put it here so that we see where it's coming from. It canceled here, but it was left there. So we're going to utilize that to get the answer. I'm going to be working mine out. I need a verification from somebody. So let me put out mine and see what I get. I'm getting 50.02, right? I'm getting 50.02. I want to write that. I need 54, should say. All right. I got 54.02 meters, and that is BP. I need somebody to verify that for me, please. Thank you.
Confirm.
Yes, sir.
Confirm. Very good. Very good. And guys, if I make a mistake, don't be afraid to raise your hands. I won't be ashamed because I'm good. All right. I don't worry about those stuff. All right, let's go. All right, so you could see that we have already started to fill out the concept here. We have already. So what we need now is BT. Let me drop the triangle for BT. Right, where could I put it? I could minimize this a little bit, put it to the side a little bit more. Let's put it beside it. All right. I hope you're still seeing what is on the board. Assume, bring it up back for you. All right, the tangent, let me draw the triangle first for you. Let's draw that triangle first. Or we could just look at it here, by the way. No, it's a little bit crowded. Let me draw it. Let's take it off. Sometimes the crowdedness of the thing kind of. All right, so we're talking about B, T, R, and we have the 90 degrees here. We're talking about BT. This is 35. And remember, this is still 60. So you realize that it's the same thing you're doing again, you know, only that you're using a smaller angle because we intend to find BT right there. So we're going for BT with the same tangent rule. All right, this time I'm just going to put in the value. I'll say tangent of 35 is equal to the opposite side, which is where the green went right here. And this is BT, and it's divided by 60, which is the adjacent side. Now you can multiply both sides by 60 again, as you could see. So then let me move this, mark this off. 60 tangent 35 is equal, you good? BT is equal to BT. Now let's see what we have. BT, still asking you to verify. I'm checking mine though, you know. Tangent of 35 times 60. I'll say 60 first. I'm begging you to put the constant first. Put it out there, because sometimes your calculator mix up the angle. Some calculators do it, but most calculators will do it properly. But to be on the safe side, Always put the numbers behind the ratio. All right, let's go. I'm getting 42.01 meters for BT. I need a confirmation from somebody.
Yes, sir.
All right.
Yes, sir.
Thank you very much. Thank you very much. Thank you very much. All right. Now let's put it together. Let us put it together. I could rewrite it for us down here. All right. So I'm going to bring the idea down here that TP is equal to BP minus BT. Remember, we got this to be 54. Let me put equal 54.02 minus, and this that we just found was 42.01. Let's do the subtraction. 54.02 minus 42.01, and I'm looking at 12.01. Remember, they say to the nearest meter, and the nearest meter is a whole number, and this whole number is just 12. I hope that everybody agrees with me right there. Talk to me. Are we okay with this? Question, guys? Anybody?
Sir.
Yes. All right. All right. So if there's no question, then it seems like we're good. All right. We have another one here coming up. I think I have 3. Very good. I have 3 because by the time we finish this, it's going to be the first half. And then we'd want to go into some bearings. All right. So we have 3 of this. Let's look at this other one. All right. All right. This one says here, let me blow it up a little bit for us. It's almost like the first one, but it's different. I realize looking at it now. All right. It says the diagram not drawn to scale shows the position of 2 ships, P and Q. You're looking at P and you're looking at Q. All right. At anchor. All right. FT is the vertical face of the cliff jutting out of the water. So they're saying FT right here is the vertical face of the cliff. All right. So you're seeing what's going on there. P and Q are 118 meters apart. You could see this that they placed here. They gave us this distance right there. Right. Good. All right. FT is 80. We got that. And the angle FPT is 40. We got this as well. So we got all of this. A lot of things that we got from this diagram here. All right, let's see the questions that they're asking us now. All right, they said determine the angle of elevation of T from P. Determine, so if you're reading this and then flow into the question, determine the angle of elevation of T from P. That means you're going where P is to look to see what angle is here. This is 40 degrees. And obviously, white is 1 mark because they never gave you anything to do really. I've seen a lot of people see the 40 degree and did not take it because they think it is too easy. All right, so that one is 40 degrees. They wanted to know if you're comfortable looking at this and understanding that 40 degrees is the elevation of T from P. All right, very good. 1 mark, just like that. Now, the other question, though, says the length of FP. Let's stop and look at that. The length of FP. Let me put that in yellow. The length of FP right there, right here. This is what they want us to find. I am suggesting that all you have to do is just look at a triangle that FP is attached to. And I'm seeing it attached to FPT. And then I have an angle here, which is 40 degrees. I have here, as you could see, I have the opposite to it. And then I have the angle, I have the length of the side next door. That's the adjacent. So I have the opposite and the adjacent. Again, opposite and adjacent is tangent. So for this question here at II, we're going to start off by saying the tangent of an angle in a right angle triangle is equal to the opposite side divided by the adjacent side. Let's go about doing this. The tangent of 40 degrees is equal to the opposite, which is 80. You understand? 80, which is over FP. They asked us to find this. I would say to you, let us just quickly cross multiply, all right? Because what we want is under here, and I'm not about just giving you a shortcut, right? All right, we could switch out, but I'm not about that right now. Let's look. So to find FT, you could quickly just set tan 40 over 1 and employ your cross multiplication. There it is. And then the answer will just jump out at you easily. Let us write down this. We're talking about FP times tangent of 40 degrees. And this is equal to 1 times 80. We're not done. The objective is to find FP. Well, we definitely need to divide both sides by the tangent of 40 degrees. Let me write that. I think I wrote, yeah, let me fix that for you. Thank you. There we are. And that's that. At this time, what we're going to do now is just to use our calculator. So it's 80 divided by the tangent of 40. I want a verifier. I am getting FP to be 95.34 meters. We didn't get any specific instructions, so I'll just go with 95.3, 95.34. I'll go with any of those. I don't see any other instruction that told us. So you don't have to go all the way. You could stop here. That's fine. Other than that, they'll tell you exactly when and how to stop. Make sure that whenever you're stopping, you're rounding off to. Don't just stop abruptly. Look to the next digit and look at the category 0 to 4 or 5 or more. Round up or leave it, but don't just stop. All right, whenever you're going to stop, do it as a mathematician. All right, very good. Listen for the confirmation now. 95.34.
Confirmed.
Thank you very much. Now let us jump onto the third question. Let us see if we could do it right there. Yeah, we could do it right there. All right, we're gonna, oh, something is here. All right, we probably could just do it somewhere. All right, let's go. Let's see what the question says. We could, oh yeah, I forgot I can do this. I can do that. We could do it right there now. Good. All right, so here's the question. We want to determine, reading from here, so the sentence sounds nice. Determine the angle of elevation of T from Q. All right, let me clear up this diagram right now. But I'm going to put on, what do we have? Let me put on some stuff that we have. I could write it in it. So let me put the 95 here. One of the things I'll encourage everybody to do whenever you work in your math, please label the diagram as you go on. When you find stuff, put it on the diagram because it's going to allow the next question to be a lot more clearer than it would originally be. So here's a question. Determine the angle of elevation of T from Q. Angle of elevation of T from Q. So we go at Q and then do this from the horizontal going up there. So they're looking for this. They're looking for this angle right here. But let us think about it. What do we have? What do we have? Now, you would notice that, let me clear this up. Let's clear up some stuff that I want us to see clearer. All right, there it is. What I'm saying is, let's check this out. You do have the opposite side. Check it out. That is the opposite side. Another thing that you have indirectly is the fact that they gave you 118. You have found a 95.34, which means that you technically would have all of this, only that you need to look and put it together. All right, so we have all of that side. I need somebody just to put it together for me. All right, and I'm going to put the 95 up here so that I can write the total length beneath. All right, guys, I'm going to take off that 95. Yes, I'm going to take off that. All right, I need somebody now just to help me now. Check it, and while I'm drawing this line, somebody just give me that. All right, nobody did. 95.3. Yes, I'm listening. Speak.
Sir, it's 213.34.
Exactly. Thank you. 213.34. I am suggesting that we have this and we have this, and then they ask for a side opposite to it, for an angle opposite to it. Guys, employ your thinking, because now it is still a right angle triangle, so it is still the trig ratios. We're dealing with an opposite side to an angle being referred to and an adjacent side. I'm back at tangent. As you could see, they use the tangent a lot, but I can't tell you that they will always use it. but it is used 99.9% of the time with elevations and depressions. So let us go about finding this. The tangent of the angle that we are in search of is equal to the opposite side, which is 80 meters, divided by the adjacent side, which is 213.34. Now, guys, I'm not rushing anything because we really want to understand what's going on. Let's divide this. 80 divided by 213.34. Verify with me. I'm getting 0.3749, and then there's an 8. So I'm going to just reverse a little bit and say 50. All right? Because I'm going up to 4 dp. So I'll get 0.3750. All right? So I round off, right, when I reached here. All right. Now, confirm with me, guys. Remember, I round off, right? So it was a 49 with an 8 behind it. So I reached 50. Now, remember that this is not the answer. Because if you read this and listen to yourself, it says tangent of the angle. Remember, I know we don't know the angle yet, but tangent of that angle is this value, which means that we need to do what is called the inverse tan or arctan. Well, inverse mainly at CXC, we say here. So the inverse of tangent, for those who can't find it, you might have shift or second function on your calculator, touch it and touch tan, and then you will see this symbol jump down there, the tan with the -1, which is suggesting inverse. Please, somebody help me out now, verify with me, 0.3750. I am getting 20.56.
Yes, sir.
Thank you very much for that confirmation. 20.56 degrees. And that is the angle of elevation. So that is for that angle right there. All right. So that's what is going on. If you look, we have a nice 6 marks there. You could just take away because you realize that the thing is repeating so much. It's like the same things you're doing over and over and over. All right, guys, there it is. All right. I think we're at the first hour. Yes, we are. And we are now going to venture into the world of bearing. All right. So bearings is a little bit more work than the elevation and depression. So let's jump into it. All right. I'm just going to quickly remind us though of just some things that I really think you need to do your bearings, right? I don't want to waste the time, but at the same time, I really need to say it. 1, please remember that all bearings are from the north. Let me repeat. Every single bearing that you will attempt will be from the north, and bearings are in a clockwise direction. What am I saying? Well, you are required to drop a north line at every point of importance, and your bearing will come from the north. So if the point is at A here, we don't want you to do this because I've seen this and it's messy. We don't want you to write A inside that. Don't do that. All right. We are suggesting that you let this cross-looking thing be your thing that you'll use to navigate. You can put the point A anywhere near it. It is understood by the examiners that this is the point in reference. I am suggesting that the bearing has to be from the north of the point, not from the point. So let me show you what I've seen people do. They come right here and do this. You can't do that. People come right here and do this. Don't do that. All right. So I'm showing you what you cannot do. All right. All bearings must be from the north. So you're going to step up to the north line right there, and then you run your bearing. And wherever, you know where it comes off, depending on the angle you get, stuff like that. So basically, I'm suggesting that the bearing must be in a clockwise direction, like the hand of a clock. All right, guys, you know the hand of a clock move. Bearings work like that. Now, another quick thing that everybody needs to remember. You remember in grade 7, ending of grade 7, grade 8, early grade 9, I think it's grade 8, where you did parallel lines and the transversal. Honestly speaking, without this, you cannot do bearings because 9 out of 10 times you will be required to make an alternate angle link. You will be required to make a co-interior angle link. But I will say to you though, the most two things that I've seen coming out. Watch. Every knot line is parallel to each other. Please remember that. So that means if you move from this point to that point there, you're having two parallel lines. This becomes your transversal, right? This becomes your transversal. So what it means then, you know, one of the things that I see coming out is co-interior. Honestly speaking, co-interior will be all over your thing. Co-interior, meaning they're on the same side of the transversal and they are within the parallel lines. What about co-interior? Just a reminder, they add, those angles add to give 180. And you will say they are supplementary. Co-interior angles are supplementary. I'm begging you, remember this, because you're gonna see as we do the questions that they're all over the questions. That's one thing that you look out for, co-interior, look for it, all right? Another thing that you want to look for is the alternate angle and most commonly known as the Z angle. The Z angle comes out a lot. The Z angle comes out a lot. Let me fix this. Let me fix this just to show you what I wanted. Let me just take off this. All right, good. Let me put something down here because I want to show you this. I want it to look very pronounced. All right, so the Z angle will be coming out a lot. So what I'm going to do is to extend these so that you could see the point I'm making. Z angles will be coming out. A lot of times, you will have to see this. That I'm talking. It's going to be all over your paper. Because the moment you're doing your bearings, you're going to be dropping these. You're going to be dropping these cross-looking things every time. So the moment you drop two, you have parallel lines and a transversal. They will be connected by an imaginary line or definitely a line that will be given to you. I am suggesting look out for these things because any angle that is here, it is always here as well. Z angle will be coming out. Co-interior will be coming out. All right. So I'm just saying those are just, you know, just a few disclaimers you go forward into the question. All right. Let us clear this and go into the question. All right. Let us see if it makes sense. Let's go. Let me pull the question across. Hold on. All right. I think I'm ready. Here it is. All right. Push this all the way over. All right. Good. I think we can see this clearly. All right. Good. It says the diagram below not drawn to scale. Let me take out the red. I like using this one. Diagram below not drawn to scale shows a relative position, no, the relative positions of three fishing boats. All right. K, L, M. I'm going to just touch them for you. K, L. So you see what I'm talking. M. All right. Very good. L is on a bearing of 040. And mainly they use 3 digits for bearing. That's fine. It means 40 degrees. So L is on a bearing of 040 from K. That means we're going to go at K and you will do your bearing like that. 40 is right in here. That's what they're saying. Let's go again from K. From is the word, guys, from. So you go at K, step to the north of K, and then do your clockwise rotation until it touches a line that leads to L. L is on a bearing out there. So we have that. All right. Now, another thing that was said, and M is due south. Very powerful. Due south. That means you're coming straight down, you know. I'm going to do something after this. You're coming straight down. All right. So it's due south and then you come to M. That's what they say here. Now they gave us LM, which is 120. We're looking at this. And they gave us KL, which is 80. All right. Now let us see the questions that they're asking. Let's go for the questions. One. Hold on, guys. Let me take off this. Sorry about the markings. All right. 1 mark. This is a 1 mark question. All right. Maybe we do it already. It says on the diagram, show the 40 degrees. All right. So I jumped the gun. I put it on already. So they're asking us for the 40 degrees here. We already labeled that because we were just filling out as we go along so we don't miss anything. All right. So we have the 40 degrees already right there. All right. Now calculate the measure of KLM. Mark the angle every time, please. So let's mark it. Let's go. KLM. Flow with the 3 letters. Watch. Right here, they want us to find this angle right there. Now we have a number of tools to work with, right? There are a number of tools to work with right now. But watch this. Now, let me drop something for you, and then we're just going to show you why it is, let me see, why it is a 1 mark question. All right, I was just about to tell you that it looks like it's a 1 mark question down there. But watch this. Whenever I stop, I normally put up my navigational stuff. So let me put it. I am going to put up my east, west, north thing. Let me use a blue color. Look, we went south, so we actually went on the line. I always do this. All right, just draw this. And then I put up my north right here. I always do it. We know that north and then south is down here. You have east here, you have west here. Always put it up. Or there's something I should have said to us too, but I guess we'll talk about it as we go. Now, as you could see here, when you're looking out, remember the Z angle that I just told you about? Check it out. The angle they asked us for, let me mark it in a nicer color now. Watch. Watch this. Z. Z. Can everybody see that Z angle? Because remember that the north lines are parallel. So that means we're nice. We have 2 nice parallel lines cut by a transversal KL. 40 degrees is right here. Right now. And the reason for that is because we went south. That means we're on our north line still, but we're heading south. So the north lines are parallel. So 40 degrees there is 40. So this is 40 degrees, no working, nothing. Hence, they are giving you 1 mark to produce that. Is that clear with everybody?
Yes, sir.
Sir, can you please do it over?
All right, good. What you want me to show you? You want me to show you the Z angle or what? Because we're not working out this one. It's because we have a Z angle there. So let me draw it on this side. Watch. There was a north line here. This is K, and K went to L. And there's another north line at L. But I'm saying the line would be your regular thing like this. Because remember, you always like to set up this whenever you're navigating. I am suggesting here that bearings will kill you with Z angles and co-interior angles. Right now, they're taking a nice little run with the Z. Look, when I say Z, you don't have to look for a proper Z. We're talking the idea. Look at it. The Z angles, which is what we call alternate angles, they are equal when you have 2 parallel lines. So this is parallel to that. All right, so because this is parallel to that, we're able to get this. Everybody good with that? That 40 degrees here. So that's what we do here to get this one. Nothing, no working out, nothing.
Hello?
All right. All right, good. So the Z angle we use to get that. Now let us look at something else now. They're saying calculate the length to the nearest kilometer. That means the whole number you're going for of KL. KM. KM. Let me take off some of these now. Just to go for KM, let me put back the 40 because the 40 degrees is needed to work that out. We want to find KM. Look for me and tell me. We don't have a right angle triangle, and you're definitely looking at an angle between 2 sides. And they're asking you to find the side across from it. We talked about this earlier. So we're going to be using the cosine rule to find that out. All right? So the cosine rule, we could drop it somewhere here. It says the side across from the angle square, which is KM square, is equal to 80 square plus 120 square minus 2 times 80 times 120 times the cosine of the angle, which is 40 degrees. Now, for those of you who don't remember, you're utilizing the 2 sides and the angle. Just look, 80, 120, 80, 120, and the angle 40 degrees. This formula is given to you by CXC. So you look under the formula section. The moment you can identify that there is an angle between two known sides and you're going across from it to find that side here, you can utilize that formula and move on. Let us go about getting these numbers out. 80 squared look like 6,400. Work with me. Plus 120 looks like that. I think it's going to be 14,400. Remember to double check because I'm not using a cal right now. For this part though, you would have to put everything here on your calculator one time. I always tell students, put all of this one time on your calculator. Please, from the -2 right there, go all the way back. One time. You will get a negative answer right now, so I'll put it based on what I'm seeing. Can somebody verify with me what they have for -2 times 80 times 120 times cosine of 40 degrees? Tell me if you're getting negative 14,708.05. Let me know if you get this. Talk to me.
Yes, sir.
Yes, sir.
Yes, sir.
All right. Thank you very much. Thank you very much. Let's put it together now. We're going to be adding 6,400 plus the 14,400, right? 6,400 plus the 14,400. And then we want to subtract from that 14,708.05. All right. Tell me if you get 6,091.95. Just tell me if you get that.
Yes, sir.
Yes, sir.
All right. Remember that this is not the answer because this was km square. Look, it's a square. We don't want the square of it. So it means then km would mean that we have to take the root of that idea. So let us take the square root of 6,091.95 and we're looking at 78.05. However, to the nearest kilometer, I think they said that, yeah, it's going to be 78 kilometers. Talk to me now. I want somebody to just double check. Somebody asks a question. Is it okay? Are you fine with the working out? So we use the cosine rule right here. And guys, if you notice, cosine rule is just a nice flow. You don't have to swat it because it's given to you. All of the trigonometry formulas are given to you by CXC. So you don't have to stress, it's there. All right, so we have that down. Let us see if there's another question to it. At the same time, guys, anybody wants to ask a question? Oh, okay, there is no, I think there is no more, no? Oh, that's it. Okay, there is no question, that's it. All right, there is no more question for that one, all right? Yes, go ahead, somebody saying something? Okay. I'm not hearing it clearly.
I don't know the square. I was asking if you could repeat.
All right. Could somebody who heard what she said, could you advise me, please? And our mic was muffling. Anybody heard what she said?
No, sir.
Okay. I did not, the person that just spoke, I did not hear what you say because your mic was muffled a little bit. You want to just quickly repeat it? I'm listening. All right. All right. She maybe got cut off. All right. So we're going to have to move. All right.
Sir,
Yes. Let me bring it
she
back.
was asking how you got the square from the
All
PM
right.
square.
Very good. Very good. Very good. Thank you for the question. Well, it's not me who get it. It's a part of the formula. So I would just advise you that the cosine formula, well, let me just do this quickly for you because everything matters, right? Everything matters. So let me do this for you quickly. This is what the cosine rule is saying. If this is an angle here, and this is a side here, and this is a side here, this is B. The formula starts by saying C square. So the side across from the angle, square. The formula was made like that. C square is equal to A square plus B square minus 2AB cosine of, say, let us say we have, I'll just put theta here. That. The formula was made that way. So that is why we started it off like that. And please, you don't start with the unknown. You start with the side across from the angle square. Sometimes it is known, sometimes it is not known. Just now, it was not known. See it here? Km. It's across from the angle. So the formula starts with km square. That's how it is made. So if you check out the formula sheet, you're going to see that. Here. So it's the formula that starts that way. All right. Thank you for the question. All right, let's follow through on another question that came. It says a ship leaves Akron, all right, on a bearing of 030 to Belleville, 90 kilometers away. It then travels to Compton, C, which is 310 kilometers due east. All right, this is so important, due east of Akron, A. All right, as shown in the diagram below. So, all right, as shown. And one of the things we have noticed over the years, though, it's nothing like in my time when we used to draw the diagram. CXC is drawing the diagram for you. All you're doing is labeling right now. All right, so the first question says, indicate on the diagram the bearings, 30 degrees, and the distances 90 and 310. You get 2 marks to do that. That means you have to make sure that you read what they're saying. The ship leaves from Akron, A, on a bearing of 30. So it left A on a bearing of 30. All bearing are from the north of the point. So we lift it up to the north and we go like this, and this is 30. All right. All right. So that's 30 degrees right there, leading to this. And then now, let's look at the measurement that you get. The measurement that you get, 90 kilometers away. So they're telling us that this is 90. That's 90 right there. And then we also got that it traveled to C, all right? This is due east, so whenever something is due east, they're indirectly telling you that it's a 90-degree angle you're getting. Because you were told that C is due east of A, which means that there is a 90-degree here. That is the indirect thing that they gave, all right? Also, we were told that it is 310, all right, kilometers away. Now, this is a nice label, but I will say to you, this will give you the 3 marks, the 2 marks, but you will need to go ahead to highlight more things that were given indirectly. For example, I will just put my 60 degree here. Why? Because I know that the 30 and the 60 give me the 90. So I put it there because I just know that they're going to use it. All right. So let us see now. All right. So we have completed that. All right. So the other question says, calculate to the nearest kilometer the distance between Belleville, which is B, and Compton, which is C. They want us to calculate the distance between this. You're going to realize that when you're doing bearings, you're doing the same thing over and over and over. Watch. There is a 310, 90, and an angle of 60 between those. And they're asking you to find the side across from it. We have done so many of this. And this is how bearings questions are. Understand? It's going to be repeating over and over. So let us just go about now and set it up again. I'm just working based on context. And these are questions that came over the years. I picked questions from 2022 January, go all the way back. And this is how it looks. All right, so let's go. Now, the side across from the angle square is a cosine rule again, you know. So I'm going to say BC square. The formula starts like that, guys. Is equal to 90 square plus 310 square minus 2 times 90 times 310 times cosine of 60 degrees. We're putting this together. Help me put this together, guys. No errors. 8100, 310 square. What's that? About 96,001. Yeah? 96,100. Very good. Then everybody is to put all of this on it one time. one time. So minus 2 times 90 times 310 times the cosine of 60. And I'm going to write what I'm getting. You could confirm with me. 27,900. All right, so we have all of that. I need a verifier now before we start breaking this down.
Yes, sir. 27.
Thank you very much. 8,100 plus 96,100. And we're taking 27,900 from that. We're left with 76,300. Remember that this is BC square, not BC, but we intend to find BC. So you'd have to take the square root of both sides, or, you know, depending if you're working long enough, you just said, okay, let's take the square root of that. All right, good to go. So somebody take the square root while I'm taking it. Square root of 76,300. And I'm getting this, 276.22. They did say to the nearest, which is approximately 276 km. And normally when I find it, I placed it on the diagram just for the next question. That's how I work. All right, so that's that right there. You're looking at it. The cosine rule is being overused. All right, normally cosine then sine, or sine then cosine. So I assume we're going to use sine rule now. Watch this. I don't know. Let's go. Calculate to the nearest degree. I'm underlining this. And it did say the measure of angle ABC. Remember, when you're following the flow of 3 letters in dealing with angles, it's going to be the angle right there in the middle at B. Let's mark this angle. Calculate to the nearest degree the measure of angle ABC. Let's look. ABC, ABC. All right. I want to take off. I might let it stay because I'm going to use them. ABC, ABC. This turning right there. They want us to find this angle right there. Well, I'm just going to grab onto the sine rule right now, right? Because I'm going to push across from this and look at what we have. Check this out. All right, so we have 310, which is across from the angle that they asked us to find. And already we have 276, which is opposite to the 60. So we have opposite to the 60 degrees, and we have the side opposite to the angle that we need to find, or we could say across from, right? So whenever you see that, you can just gladly run to your sine rule. So let me just write my sine rule here. So I'm going to say 276 over the sine.
Sir, can you repeat that again, please?
All right. I was saying that whenever you have angles on opposite sides, for example, we have 60 degrees and we have the opposite side to it. We were asked to find this angle here, theta. They gave us the opposite side, 310. The moment you're dealing with angles and opposite sides, I would advise you to use the sine rule. All right, A over sine A, B over sine B. So we are employing A over the sine of A equal, let me write this, let me write this better. This is ugly, hold on. Let me just fix this. All right, here it goes. We are employing A over the sine of the angle at A, which is equal to B over the sine of the angle at B, which is to say 276 over the sine of 60 is the same thing as 310 over the sine of the angle that they asked us for. So we're setting up that. Let me push this up forward now. All right. So in pushing that up forward, we could quickly do a quick cross multiplication as we venture off in this world. This goes with that is equal to that goes with that, right? So the cross multiplication works a lot of times. So we're saying that 276 times the sine of the angle that I need to find, that is equal to 310 times the sine of 60 degrees. Now remember what you want to find. The aim is to deal with this. So then we have to get rid of that 276. So we're going to divide both sides by 276. Now let us cancel. Now let's, on our calculator, we need to work out 310 times the sine of 60, and that looks like one. Let me not say. Times the sine of 60. Hold on. Where am I? Sine of 60. All right, good. And then you're dividing that by 276. All right, I want somebody to verify with me that we did get the sine of the angle is 0.9727. 0.9727. But that's not the answer. All right, so the answer is that we're going to have to sine inverse 0.9727. Let's sine inverse that, please. And then whatever we get is the angle ABC. All right, so let me sine inverse 0.9727. Make sure that I use the right number, please. All right, we're looking at 76.58. And then there is a special instruction. So it's going to be approximately 77. Why? Because they did say to the nearest degree. So then we're highlighting the 6. Then we're going to look the next number there. And then it's a 5. So the 6 will round up to 7. And 77. All right. So it's a 77 degrees that they're looking for. Let me put my little degree here. 77 degree is what they're looking for there. I trust that you see what's going on. Like, it's very repetitive. You could see that they're repeating the ideas over and over and over and over. All right, let's see what goes on, because we have a few more to go and we have about 33 minutes to go. All right, here is the 2022 question. So this question just came, like literally it came like 3.5 weeks ago. Here it is. This is what came. So I'm just saying to you, we're not hiding. We're saying that this is what is coming. All right. So let us see how it will go. Somebody was, yeah. All right. Yeah, you will get the recording, guys. I'll tell you what's going to happen soon. All right, let's go. All right, let us look at, oh, let me draw this. I think I'm overlapping on something. Am I? Oh, there's another part of the question. Guys, there's another part. Let's pull down this a little bit. There's another part to the question here. So let's do this. All right, I didn't see it. It was the other diagram jumped on it. All right, let's do this before we go to the next question. It says, determine the bearing of C from Belleville. All right, these questions are nice now. So determine, look, let us look carefully. This is very important. Determine the bearing of Compton, which is C, from Belleville, which is B. From B, please, from B. So we're going to go at B now. Let me look at the diagram. All right, let me clear up this diagram a little bit so that the question may have more worth in terms of you looking at it. We could put the angles that we get. I'm going to put the angle that we get here. I think this was 77. Make sure that it is correct, guys. I hope. All right, determining the bearing of C from B. From B. Where is C? Right here. Okay. From B. They want C from B. Let me mark it in a purple color right here. Now, you would agree that the bearing of C from B, that means you go to B and you do your clockwise rotation until it touch a line that leads to that. All right, there are a number of solutions, all right, but I'm just going to touch one for you right now. So let me clear up the road that I'm going to touch. Watch this. I want you to see something. I'm going to put another color here so that you could see a point I'm going to make right about now. I'm going to put it in that blue. Watch. I want us to observe all these angles here. And you would agree that you have an angle at a point. Like right now, when you look at this, you would agree that we have an angle at a point right here. The point B, we have a 360 degrees going right there. Can anybody just confirm with me? We have a 360 going on. Purple, red, and the blue together is a 360. Now, we can find this nice blue here on the left by using up the co-interior. Remember, I told you, look, north line, they are parallel. I'm getting a co-interior here, and this is to say that the angle here at B is 180 minus 30. So you're talking about 150 right here. Right here is 150. Now I'm saying, you know, whenever you're solving bearing, you know, all you have to do is to relax, label your thing, think. Because right now I'm not going to employ any form of trigs because I'm seeing an angle at a point is always 360 degrees. Now, if I can add my 150 plus the 77 and subtract it from 360, I will definitely be left with that, which is the bearing. So guys, some of the times it's going to be a little easier than what you're thinking. But if you're thinking too much, you're going to be looking for things that, you know what I mean? I'm not saying you couldn't do more stuff, but it's a waste of time when you can just look and see, okay, co-interior, this is 150. Oh, angle at a point, 360. Hey, just move on. So in this case, we are talking about the sum of that. Let me just write the sum of this. All right. 360 minus 150 plus 77. So this is 227 you're taking from it. Somebody just do the calculation for me. 227. This out here is 133 degrees. I'm not suggesting that that's the only way, but I'm just saying that this is one of the easiest ways to just navigate based on the principles. You haven't touched trigs to get that bearing yet. Can you guys relate to that right there at the angle at the point?
Yes, sir.
All right. So that was what this was about down here. 3 marks for that, you know? 3 marks for that 133. So the moment you can see what you're doing and you just work with it, you're good to go. Remember, you will be provided with the recording to rewatch the parts that you want to watch, or you want to watch it over from scratch. Fine, but you're gonna get this. All right. All right. Good. Let's jump to the question that came January of this year. This is it. All right. It's a little bit, well, it can work. It's good. It says though, let me read for you. It says the diagram below shows straight roads connecting towns L, M, N, and R. You're seeing the towns. Let me mark them. That's L, M, N, and this is R. All right. Very good. It says LR is equal to 18 kilometers. It's given. So I'm going to just touch beside it. So let me just touch it. LR is 18, sorry. LN is 12 here. MN is 10 here. And the angle RLN is 25 right there. So it's well labeled there. And then we have a 88 degrees up here, LMN. They gave us this. And they gave us, is this 50? But I don't see they tell us about it though, but it's there. Hold on. Okay, they didn't tell us, but there's a 50 degrees I'm looking at right here. I don't see the labeling for it. All right, there's a 50 degrees here right there. All right. All right. So let us now see what they're asking us to find. All right, let's see what they're asking us to find. Calculate angle MLN. Mark the angle first. No, it's MLN. Mark the angle. Let me mark this angle for us there. They want us to find that angle right there. Guys, check it out. Check out that. So we can easily employ a strategy to find that right now. There are so many things you can do. You can say, all right, let us jump on that sine rule. Because as I said to you, everything is repetitive. I have 88 degrees. I have the side across from it, which is opposite to it. They asked me for this angle and they gave me the side opposite to it. So right there, I'm going to employ my sine rule. So I am suggesting that we could start off by saying 12. Hold on, wrong marker. Let me switch this marker. Thank you. Let's go. We could say 12, which is this 12 right here, over the sine of 88 is equal to 10 over the sine of the angle I intend to find. I can just put theta for now and then I rename it when I'm done. We are going to cross multiply again. So we're doing the same things. This question just came, but it is operating the same way because that is what bearings is. There it is. So let us just quickly do our cross multiplication. 12 times the sine of theta is equal to 10 times the sine of 88 degrees. My intention is to find this. So therefore, I need to divide both sides by 12 in an effort to have the sine theta alone. So now the sine of the angle is equal to, let's put that on our calculator, 10 sine 88, divide that by 12. I want somebody to verify. I got 0.8328. But remember that this is not the answer. So we're going to have to have sine inverse of this value, and then the angle will come out to us, and the angle is MLN right there. Can somebody help me out with that? I need a verifier. 0.8328. Hold on.
Verified.
Do you get 56.39?
Yes, sir.
Thank you.
Yes, sir.
Thank you very much. 56.39, I got that too. Thank you for the verification. 56.39. There is somewhere that I really want you to put this on. So I'm going to take off these. These were for our little working. We take them off now. Take them off now. I am saying I would love you to label right here. Because at the end of the day, somehow you might use by that. So we'll put it there so that the next question will be a little bit clearer to us. All right. These are 3-mark questions, you know, guys. So it's the 3 marks there to employ that. The next question that came January of this year says, calculate the distance NR. Let's go and look where NR is. Look at this. Look at this. This is NR. Now we're asked to find NR. I'm going to put NR in yellow over here. They want us to find that. But let us look to see what it is we have. We do realize that we have an angle between 2 sides. Check it out. Nah. And then they're saying to us, why not just find that side across from the angle? All right, there it is. They want us to find that. So we are saying that now we're going to set up our cosine rule. No, cosine rule. All right. So let me catch the diagram there to look at it. Cosine rule is saying that, guess what? The angle across, the side across from the angle, or the side opposite to the angle, which is NR. NR square is equal to 12 square plus 18 square minus 2 times 12 times 18 times cosine of the angle. So I'm just writing that out. I'm going to push the screen up. So NR square is equal to 12 square plus 18 square minus 2 times 12 times 18 times the cosine of 25. Now for somebody, just double check. Here is the 25. This is what we want. 18 is right here and the 12. So you're seeing that, okay, bearings does not get harder enough because these are the questions. Let's go. Somebody help me out now. I think this is 144. 18 square, it might be 324. Let me double check that. 18 square. Yeah, it is. All right. And then now you're going to put everything on your calculator. Negative 2 times 12 times 18 times the cos of 25 degrees. And tell me if you get this. I'm getting negative 391.52. All right, that's what I have right now, up to date. So what I want to do now is to just continue working. 144 plus 324, and we're going to subtract 391.52. And we're looking at 76.48. All right, hold on, this does not write well. All right, let me fix that for us. All right, good. All right, little better. 48, that's it. So NR, because remember we have NR square from the beginning. So we're talking about NR with the root of 76 point, right? So take the root of that and we're getting something near like 8.75, somewhere there, 8.75. And let me see if they had given us any specific instruction. Hold on. No. All right. No specific instruction. So you could put 8.75, or you could put 8.8, but 8.75 is fine.
All numerical values should be written to 3 significant figures unless otherwise stated, right, sir?
All right, very good. All right, guys, remember that. 3 significant figures when you're not told. All right. All right, guys, are we okay up to that point? Hold on, is this it? Okay, I thought there was more question on this. Okay. All right. Let me look. Oh, all right, there's more question on it, man, because it's long. Oh, it's a small question on it. Okay. All right, there's one other question on it. All right. And it says, determine the bearing of T from tone N. So from tone R, my bad, let me read over. Determine the bearing of tone R from tone L. From L, right? So R from L. Let's go up and look. Visit the question. Don't be afraid to go back and look a million times. All right, let me clear off all of this. Let me clear off all of these just so that we're seeing what they want. All right. They asked us, let me put this in a red. They said, determine the bearing of R from L. R from L. That means you're going to go to the north of the point L. They want all of that. All of that. See, it leads to R right here. They want all of that. No problem. It's a 1 mark question because the bearings, the values are there. 50, 56.39, or 56.4, and 25. All right. So let's go. Let's go right there. So we have a 50. All right, hold on. 50 is here. 50 was there from the beginning. We found 56.39. We could have 56.4. All right, and we have a 25, right? Let me double check if it was. Yeah, I think it was 25. All right, good, 25. So all we have to do is just to put those together, just add up everything. Hence it's a 1 mark. It's just a 1 mark because they knew that everything was already there. All right, double check with me. It's 131.4. All right. So that's the bearing right now, straight up. Straight forward. All right. Let's jump on.
Correct,
Let's go ahead. Listening. Oh, you're confirming?
Yes, I'm confirmed.
Thank you very much. All right, so here it is now. We have this one. It says the diagram below, not drawn to scale, shows the positions P, Q, and R. So three ports, P, Q, R. We're looking at them. Where is P? We have P here, there's Q here, and then there is R right there. All right. So here's the thing now. This one, they didn't have a lot of sentences, but they're just having some little bulletins. Like they said, all right, Q is 8.
Sir.
Yes, go ahead.
So you can just go back up for the last question.
The last question, right there.
Yes, sir.
You're okay now? Can I go back or what?
10 seconds.
Okay, just advise me. Ready? All right.
Is that
All right,
25 plus 131.4?
Yes. Yes. All right, good. So you're right there. All right. So for this question now, we're told that Q is 80 kilometers from P. It's given here, right? You're also told that R is 100 kilometers from Q. R, 100 from Q, And then additionally, on a bearing of 0.66, all right? You notice this is not on the diagram. You could put it on because it is R is on a bearing of that from Q. So from Q, R is on that bearing. So we could just put this in right now. Normally, I label it as quickly as I see the things. All right. So we have that. Now, we also got another angle. It says angle PQR is 54. It's there. Right there. We're looking at the 54 right there. Now, let's see what they are asking. First question. All right. Calculate the bearing of P from Q. P from Q. Look at it. P from Q. Let me put this in a different color marker. No wonder why they left off that angle up there. It's based on what they were going to ask. The bearing of P, but from Q. So you would have gone at Q and then do your clockwise thing until it reaches a line that leads to P. The bearing of P from Q. All right. Now, when you look at this though, check it out. Luckily, well, I don't even know how to give 2 marks for this. I guess they want, oh, I think I know how. Because one would have been to interject that 66 that wasn't there, and the other one is the 54 that was given. Because you would notice that if we add these 2 values there, we would have gotten the full angle, which is the bearing right there. So this bearing is 66 plus 54, and this looks like 120 degrees. So that bearing is 100. Verify with me, guys. Verify. Yes, it's correct. So that bearing is 120 degrees right there. So we have that. I don't want to ugly up the diagram, so I'm not going to put it out there, but I put it down here. Look at the next question now. The distance PR correct to 2 decimal place. PR. Well, as you could see, you know, we have 54 in here. They want PR, which is across from it. And then you notice that you have the angle between 2 sides. So we are back to the cosine rule. As I said to you, it is very repetitive. So we're talking about PR. Let me start up here. PR square. All right, hold on. Let me write that better. Give myself some space to start it. All right. So I'll say PR square is equal to, we could say 100 square plus 80 square minus 2 times 100 times 80 times the cosine of the angle, and it is 54. 54 degrees out there. Give me some values now. I think this is 10,000. I think this is 6,400. And then we put all of this on the calculator one time. Negative 2 times 100 times 80 times cos of 54. All right, I want you to help me out. I'm getting 9404, as in 9,404.56. I'm getting that right now. All right, so I need some persons to just verify as we go along that these numbers are
Yes,
good.
sir, that's what I got.
All right, thank you very much, sir. All right, so let's add up and subtract the 9,404.56. And I'm looking at a value of 6,995.44. All right, are we good there?
Yes, sir.
And then to find PR, you're taking the square root. Square root 6,995.44. 44. Square root 83.64. All right, there's a 638.64. Let us see if there was any special instruction. Where are we? Oh, yes, it's 2DP they asked for right here. So we're just working. So let me write what was there so that some people could see why we stopped there, because I don't like to jump the gun. All right, let me just put it for real. So this is the real thing. There was a 8-3, there was a 6-3, and then there was a 8 and a 7. But since they want 2, we'll stop here, but we can't stop, we have to round off. All right. So definitely you're seeing that we're looking at 83.64 because the 8 would have round up that, all right? Good to go. So that's what they are looking for there for you to get the full mark. If you leave off that rounding off, I can guarantee you is 2 you're going to get out of that, 3. All right, not bad. Next question says, the measure of angle QPR. Remember, following the 3 letters, it's the middle. So QPR is right here. They want us to find this nice angle right here. Now, as you could see again, let me take off some things here so we could have a little bit more clearer stuff as we go along. Now, we had found out that this is 80. Let me write it. This is 83.64 right there. So I'm saying they want us to find that angle here, and they gave us so many clues. They gave us 2 things that worked already. So 54 and the 83.64 opposite to the 54 there. And the angle that we intend to find, 100, is the opposite side. I'm going to employ the sine rule. A over sine A is equal to B over sine B. So let's write that on the side here. All right, so we're talking using A over sine A. I'm just going to jump into it. So I'm going to say 83.64 over the sine of 54 degrees is equal to 100 over the sine of the angle we intend to find. Again, I'm just going to say you could cross multiply with these whenever you see them. It's okay. No stress. So we're saying then that 83.64, why is my 6 looking at that, times the sine of the angle is equal to 100 times the sine of 54. All right, we're almost there. Let your calculator do the work. We'll divide both sides by 83.64. 83, hold on, let me write it, 83, good. 0.64. Help me now. Let's work this out. This is the sine though of the angle. All right, calculator at work. 100 times the sine of 54. If we divide this by 83.64, I want a verifier. I get 0.967, and then we're gonna have to go 3. All right, I'm using 4DP here, so 3 is good. Since there is a 2, 6, stop at 3, no, 7, 6, 7, 2, 7, 3. All right, 2, 6, so we round that off. So the sine inverse of 0.9673. Let's put that on the calculator, and then it's gonna be the value of the angle QPR. Let's go for it. Sine inverse 0.9673, and that's 75.30. I'm getting 75.30. But remember, everything is in context of what the question wanted. And the question did say to the nearest degree, which means that this is approximately 75 degrees right there. 75 degrees right there. All right. So that's another 3 marks right there, and that's 8 solid marks you could have walked away with just by doing those. 8 solid marks. All right. All right, let's stop there for a moment just to discuss because we have like 5 minutes to go. All right, guys. Definitely, I would like to know the topics that you probably would want for the next time we meet, which is March 13. All right. I don't know if you're going to say what you have now, or you're going to pass it on to Miss Hall to say, but we could decide now quickly on a number of things that you could want, because you are the best person to tell what it is you would want the next time. It doesn't matter to me what topic you choose. Just
Sir,
pick
they're
what you
very-
want. Let me write them down right here. Just list them quickly.
Sir,
Yes.
variations and vectors.
All right. All right. Sounds nice. Vectors. All right. The vector, all right, the variation, you're going to love that. The vectors, you're going to love it as well. All right. Variation and vectors. Sounds nice. All right. Good. All right. Anything else?
Relations and functions.
Relations and functions. All right. So I'm just going to put functions here. All right. / relations. Yes. All right. Very good. All right. All right. So what I could do, because in a 2-hour span, I could do like, if based on what we see here, we could do like 3 each. We could try to 3 of each. All right. All right. Sarah, you raised the hand. Go ahead, Sarah.
No, Mr. Wendell Edwards, what going? I'm here, yellow man.
Oh, okay. Okay, my big brother.
You never know, but beer things.
Ryan.
See, all right, Siggy Figgy.
No, sorry, man. Go long.
Look, my boss.
All right. All right, guys. So as you could see, we're going to be looking at these. All right. I may switch on the order. I will start with the simpler one, which is a variation, and then we jump into functions, relation, and anchor it with vector. All right. So we'll do that.
Somebody said quadratics, sir.
Quadratics. All right.
Somebody wrote it in the chat.
All right. Good. All right. So I'll see how best we can organize ourselves around that. All right. Somebody was asking about the recording now. What I'm going to do is that I'm going to publish this by tomorrow so that you can have it permanently. So it's going to be placed on my YouTube channel. This is the channel that I have currently. All right, so it's entitled Delimat's Concepts. All right. Currently, there is over 100 and probably 30 something videos now already out. Matter of fact, the January 2022, every question from question 1 to question 10 was solved on it, 1-1. So I did question 1, then I did question 2, then I did, so I just took the time just to re-explain, make sure that it was clear. That's already on it, and hundreds more videos. All right, so you could check out that, subscribe for notification, because I do almost a video every day on some CXC question or AdMaths, and some pep is on it, but to a lesser extent. So it's mainly CXC and AdMaths along with them. The open sessions that we're going to do April 3rd, when I said I'm going to start to solve a CXC past paper from scratch, and we'll just go through whatever comes on the paper, and wherever we stop, we'll pick up back the next time. Those sessions will be done on YouTube Live. So it's not going to be like a one school now. It's going to be like whoever wants to log on, we try to just empower everybody by then. But for now, I'm focusing on about 5 schools, including you, and we'll do that. We'll do a double, and then we go open April 3rd. Then it's YouTube Live. So you want to subscribe to the channel to know what's going on, and you could check it out, check out the videos, because there are a lot of videos. And those of you who are doing AdMaths too, I do some nice AdMaths questions as well from past papers, you know, so you could see what's going on up there. Any question that you'd like to ask? We are almost at the end. All right. If there isn't any question, I guess, Miss Hall, are you still there?
Yes, sir, I am.
All right, Miss, thank you for having me. And we are at the end.
Yes, sir. Thank you so much, Mr. Wendell Edwards. You would have seen his name, and you see the last name as well. Yes, it is Mr. Edwards' brother. You can't miss it. They look so much alike. Thank you so much, Mr. Edwards, for having us as well, and for giving us all of that information, especially about your YouTube videos. And I just want the students to show your appreciation by using the reactions. You have your reactions there, you know, you can give a clap, you can give a thumbs up. We want to see the reactions coming in, so let us see them coming in from you. I'm just gonna allow Mr. Edwards to